Okay, so we're going to be starting lesson or unit 11, Introduction to Statistics. I forgot that right there, section 11.1. So we have a lot of definitions here. Let's go and start piling through those and see what we got. So statistics. Statistics is a study of how to collect, organize, analyze, and interpret numerical information from data. The purpose of statistics is to find meaning in data and communicate it to others. So as we start doing things, what is an individual? So when we start talking about statistics and stuff like that, we're going to identify different things. Individuals are the people or objects included in a study. A variable is a characteristic of the individual to be measured or observed. Data comes in a couple different types. We have what's called quantitative variable, is a value or a numerical measurement for which operations such as addition or averaging make sense. Qualitative or categorical variable describes an individual by placing the individual into a category or a group, such as male or female. A lot of times people just think of it, quantitative deals with numbers, qualitative deals with groups that aren't numbers, but you can have numbers and categorical also. We have population data. This is data from every individual of interest, or sample data, which is just from a small group of individuals of interest, okay? Only some of them. So some of the population would be a sample. When we talk about a population, we use parameter as a population parameter is a numerical measure that describes an aspect of the population. So we call it a parameter. If I do a sample, we call it a statistic. And it's the same thing, just a measurement that describes the aspect of a sample. Descriptive statistics involves methods of organizing, picturing, and summarizing information from samples or populations. Inferential statistics involves methods of using information from a sample to draw conclusions regarding the population. A statistical question is a question that can be answered by collecting and summarizing data. So, a lot of definitions and stats. Here we go. Here's an example. Is a given question a statistical question? Explain. Which is the most popular visual art form? Photography, painting, sculpting, or drawing? And B is, how many lithographs are created by the artist M.C. Escher? So a statistical question is a question that can be answered by collecting data. Okay, so which one do we think is a statistical question? The top one is yes. The bottom one is no. This one is a one we can easily find the facts for. The top one requires us to take people's opinions, gather some information, asking questions of other people what they think, and then gathering the data from there. So there's that question. Let's look at another example. This one's going to work out. See, I got to zoom out a little bit so you see a little question. So here's an example of a problem or identifying some information. So what is the average miles per gallon for all new hybrid small cars? Using Consumer Reports, a random sample of such vehicles gave an average of 35.7 miles per gallon. In this statement, we want to identify the variable. We want to know if the variable is quantitative or qualitative, and what is the implied population. Okay, so remember, the variable is a characteristic of the individual to be measured or observed. Okay, so what are we looking at and observing for? Well, the miles per gallon. Okay, so our answer here is going to be the miles per gallon for all new hybrid hybrid small cars. So that would be the variable in this one. Is this variable going to be quantitative or qualitative? Well, I think the key word here, because I can average things, what is the average miles per gallon, is kind of like a very big leading indicator that it's going to be a quantitative. Because quantitative data is ones that we can easily average. And what is the implied population? So in other words, if this is a sample, because we did a sample, okay, a random sample, so what is the whole population the sample came from is what they're asking for. And that is very simply all new, hybrid, all of them, okay? Small cars. This one should have the word all in. So that is all of them, and we took a sample from all of them. Okay? So that's kind of what we're going to be asking you to do some questions on, identifying the different parts of our analysis. Let's see. When you are unable to gather data from an entire population, you need to use a sample. One of the most important sampling techniques is called a simple random sample. A simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. Okay, so the important part of a simple random sample is making sure everybody has this, every sample you do of whatever size you choose has the same chance of being selected. Okay. So here are some features of a simple random sample. Every sample of specific size n from a population has an equal chance of being selected. No researcher bias occurs in the items selected for the sample. And we'll talk about that here in just a moment. A random sample may not always reflect the diversity of the population. Okay? So we're not trying to make that happen. We're just trying to have a group chosen, and every group that I can choose has the same chance of occurring. So, for example, the population of 10 cats and 10 dogs, a random sample of size 6 could consist of all cats. It's not likely, but, well, it's equally likely, I should say, because if you think about our probability that we did, you're just basically taking 20 objects and choosing 6 of them. So they could all be cats. Okay? And every of those groups is equally likely to occur. One selecting a simple random sample is to use a computer or calculator random number generator or a table of random numbers. Okay? Most of the time we just use a calculator because our phone can do random numbers and things like that. And I'm going to show you how to do that on our calculator. A simulation is the numerical facsimile or representation of a real world phenomenon. Okay? And so now I'm going to use an example. Right? So in this example right here, we're going to use a random number generator. Get into a new page. Right. Use a random number generator on your calculator to simulate the outcome and toss it a fair coin 10 times. I'm going to show you how to do this on your calculator. So how many, let's talk about this. How many outcomes are possible when I toss a coin? So if I toss a coin, how many things can happen in reality? There are 2 things that can happen. They are either going to be a what? A heads or a tails. Let an even digit in a random number generator represent the outcome of a heads and let the odd represent the tails. And we're going to randomly generate 10 numbers on the calculator. I can do this a couple of ways. It just depends on what you want. You can go over here to menu and probability. And down here you'll see random. And then I can do a random number. Okay. If I do a random number here, it's going to give me just any number, whatever. And that's one of the ones we're going to do. Let's go ahead and select that one and see what kind of number it gives us. Random number. It's probably asking for how many digits. Let's put 20. See what happens. So here's a random number. Okay. Then I'll give you 20 random numbers. You can see there's a comma in between these things. So based off of this first number right here, I have a lot of digits in there. Okay. So I need 10 digits. So I can just take, starting at the 8, I can just go and write down all until I have 10 digits. So that's what I'm going to do. So I created a random number. Let's do it again. Maybe make it 1. Let's just do one number here and take that number there and make it easier to see. So I'm going to write that number down. This is what the numbers I saw. 24039 3301 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we don't need the last one. There we go. There's 10 digits right there. Done on a random generator. I took the first 10 numbers. Each of those numbers being an even digit represents heads, an odd digit represents tails. So let's transform this into the H and the T. Even and even and even. So 0 is considered even. So I have heads, heads, heads. Then I have 1, 2, 3, 4 odds. Then I have an even. Then I have 2 more odds. So this will be the result. Okay? So that's how I can do a representation of tossing a coin 10 times using a random number generator on a calculator. And I can do this again. If I generate 10 more random numbers on the calculator, so if I do it again, do I get the same results? And clearly I'm not going to get the same results. Those numbers are now different, right? Now I have an even, odd, odd. So I have an HTT. So that'd be a different result. So the answer to this is no. There's way too many possible outcomes in here. In fact, if you remember from your probability, we know that there are 2 to the 10 different possible strings here of 10 H's and T's. Although it is possible to get the same one, it's highly unlikely to get the same one. Okay? So, make sure it's lined up again. Okay. Planning a statistical study and gathering data are essential components of obtaining reliable information. One of the first steps in planning a study is to determine if they are going to use the entire population or a representative sample. So it just depends on what you're doing. A census are measurements or observations from the entire population. Okay? A sample is measurements or observations from part of the population. You have an observational study. This is observations and measurements of individuals are conducted in a way that doesn't change the response or the variability being measured. Variable being measured. An experiment is a treatment is deliberately imposed on an individual in order to observe a possible change in the response or variable being measured. Observational, you want to be like hidden away. You don't want to be part of it. You don't want to have to make any changes to it. And the experiment is you're actually going to impose something on an individual. All right, so what type of study is being described? A gym asks its customers if they would prefer a gym to open earlier in the morning. Okay. A gym tries out a new weightlifting method to see if it will build muscles for the customers faster than the current method. And a gym counts the customers who come before 8 a.m. The first one represents what's called a sample study. Okay, they're asking the customers, so they're gathering their information as from the customers that they have. Here, you're going to ask them to try a new weightlifting thing. So now we are imposing a change on them, or they're doing a treatment. In other words, we're changing the individuals in such a way. This would be an experiment. And the last one, they just count. They don't even talk to the customers. They're just counting how many come before 8 a.m. So they're not asking them anything. They're not doing anything to change their routines or anything like that. This is the observational. Okay. There's that one. In designing a study, it is important to avoid any bias. A study has bias if it is systematically produces results that misrepresent a population. There is a personal bias where your personal feelings taint the data, and statistical bias that has many other possible causes. And most of these we're going to go beyond the scope of what we're going to be talking about, but not all of them. So here's another thing that happens. You may have heard of this before. It's usually involved in medical treatments. It's called the placebo effect. This can occur when a subject receives no treatment, but incorrectly believes that he or she is in fact receiving treatment and responds favorably. So this is what happens in medical studies a lot. When they're testing out new drugs and stuff, they'll have a control group, and then they'll have the group that gets the medication. And for some reason, somebody in the control group who do not receive the medication could actually believe that they are indeed getting the medication and believe it's helping them, and so then they respond by getting better. That is called the placebo effect. Okay? So that's something that pops up in those situations like that. So let's look at another example of a study here. All right? Not necessarily a placebo effect. This is just another study here. A soft drink company calls 500 people at random and asks, is our product or our rival's product the best soft drink on the market? Why is this question a potential source of bias? What could possibly occur here? Okay. There's a lot of things that can cause this to be biased. There's so many of them, I can't really list them all, but one of them could be you're calling 500 people. Okay. The reason why I might not get reliable information by just randomly calling people is because there's the I don't want to answer people. No, I don't want to take your survey. Okay. Well, that's part of the 500 people. They didn't even respond, so you don't have a response from them. Okay. It also could be situations like a bias built into this, and you may not even be intentional. And one example of this would have been, okay, let's say the soft drink company is Coca-Cola. Coca-Cola is based out of Atlanta, Georgia. So what if they call people in Atlanta and ask this question? Hey, people who live in Atlanta who drink Coca-Cola their entire life and never anything else, is our Coke product better than Pepsi? Of course they're going to answer, well, yes, I've only drank Coke. I like Coke. It's my favorite. Pepsi is the enemy. I mean, probably these 500 people, half of them probably worked at the Coca-Cola plant. You don't know. So that's one of these. This is where a bias can come in. All right. If they don't do their questions properly. And this is why you got to be very careful with those surveys that they talk about on the news all the time, where they say, hey, look at all these people say they want this to happen. Well, who are you asking? How are you asking? If you don't know how the questions are asked or how it was formulated, there could be a bias in there that they may not be aware of. And in some cases, I do believe some of them actually know that there's a bias there. It's all can be used a lot to manipulate people into believe something that's not really true. The other thing, when we call people, they could lie. Okay, they don't have to answer. They can lie on purpose. They can do all kinds of stuff, and that will create why we have a biased question here. Okay, let's look at another example. All right. So this is about bias. Why would this could have biased information in it? A uniformed police officer interviews a group of 20 college freshmen. She asks each one his or her name, and then if he or she has used illegal drugs in the last month. Why would you think that would be a bad way to collect data or to use that data? Well, I think very clearly because they probably aren't going to tell you the truth. I don't think any college person or any person whatsoever is going to tell a uniformed police officer, oh, yes, I use drugs all the time. They're probably just going to say, no, they don't. Statistics saw some data that shows that the cities with more low-income housing have more homeless people. Does building low-income housing cause homelessness? No. That conclusion is not very good. That's the problem with this kind of thing. You can, just because something has a connection in that fashion does not mean it's the cause of it. Okay? There are many other reasons, such as the size of the city or whatever the case may be, about low-income housing and homelessness. Okay? So that's what's wrong with that one. A survey about food in the student cafeteria was conducted by having forms available for customers to pick up at the cash register. A drop box for completed forms was available outside the cafeteria. What's wrong with this form of data gathering? Okay, well, first off, you're only going to get forms from people who actually pick up a form, and many people will not, so it's a voluntary response. Okay, and people who do voluntary responses are largely more negative than positive. Very few people will actually put comments of positive responses. More likely, it'll be a negative response, and you have to be really negative to actually do a response. So you're only going to get very tainted information in this fashion. Extensive studies on coronary problems were conducted using men aged over 50 years old as the subjects. So what's wrong with this data here to use to draw conclusions? Remember, because stats, we use it to draw conclusions. So if I gather this information, it's important to understand that it is only for men over age 50, okay? And you cannot generalize this information to anybody else, okay? You can't use it for, younger men. You can't use it for women because it's not for them. This is the study only for men. So there's only information in a small group. You can't go beyond that group to get effective data and make conclusions from that. Now, the last little bit right here, I'm just giving you some, there's more ways than doing a random sample. Here are some other sampling techniques I'll lay out for you right here. Just know that they're there and some of the risks for biases that can occur. A stratified sampling. So how do I pick people for my group, my studies, basically what it boils down to. Stratified sampling is when a population is divided into groups with similar characteristics, and a sample is randomly chosen from each group. So it's hard to see the color difference here, but you group them up, and then you pick randomly from each of the groups. Cluster sampling is when a population is divided into convenient clusters, and entire clusters are chosen at random as the sample. So it could be like the state of California. I want to get a good case around the state of California. So what I'm going to do is I'm going to make little groups of like all the cities, okay, of a certain size or whatever the case may be. And then I'm going to choose randomly from those cities for people. Could be that case. Systematic sampling is when you start with one member chosen at random, then use a rule such as every third member of the population to select members of the sample. So in other words, I could start with, let's just say for the sake of argument, I could start with the first person whose last name starts with the letter J. And then once I have that person, then I'm going to pick, and then from there, from my roll sheet, I'm going to pick every third person being my sample from there. Okay? Just be careful to avoid certain biases in these ones. These are pretty good methods for grouping people up. These over here have a higher risk of bias. Convenience sampling, okay, is choosing subjects that are in close proximity. So it'd be like the person that goes out to the mall and wants to take a survey of teenagers. And so they just ask, teenagers that walk by them, hey, can you answer a question for me? That's a high level of bias can occur in there. Self-selected sampling is used using a sample method made up of volunteers. That would be like the survey where you fill out a questionnaire, at the cash register kind of a thing. Okay. Or saying, hey, answer the survey, and you send it out randomly. Some people aren't going to answer it. Okay. So they self-selected themselves to take the survey, that kind of a thing. And so high risk of biases in this one. Be familiar with these different types, but know that they exist, kind of a thing. And make sure you add them kind of to your notes so you kind of have an idea what they are. Okay. So we'll do some problems together in class, and I'll see you then.